Okay, welcome to the first video I am doing for this module. This is going to be a module on factoring and on rational expressions. This is actually going to be a video based on lesson 3. I've skipped over lessons 1 and 2 because we've already done the factoring in the class. So we should know how to do that. Great review. Strongly recommend doing this. I'm going to get into the rational portion of this. The one thing we should learn is if you know how to do the factoring, which we do and you guys did fantastic on, if you know what a fraction is and how fractions work and understand that, then this unit becomes actually pretty straightforward. That's why I love this unit, because it's fantastic in taking the factoring and your true understanding. Do you truly understand fractions, and putting that together and making a whole new topic. There's even a lot more fun with this when you hit grade 12 pre-cal, and that's when you get to start graphing these same equations, and that's a lot of fun actually. The first thing what we're going to do is we're going to look at what is the domain. So we're looking at all these examples, and these examples all have the x value. So of course our domain is going to be, as we've seen in all our other graphing before, element of all real numbers. So x can go on forever. But being rational or fractional, we have denominators, and denominators cannot be equal to 0. So that's what we have to do, is to take these, look at our denominators, and determine what can x not equal, and then fitting that into our domain of our x values. So fairly straightforward. Our first one here, we have x minus 1 is divided by x minus 2. So we know our denominator cannot equal 0, therefore x minus 2 cannot equal 0. We solve the equation as we do normally. So we add 2 to both sides. So x cannot equal 2. Then all we have to do is write this, and we're going to write this in set notation. It cleans up very nicely for this. We're looking at the set of numbers where x is such that x is not equal to 2. And x can be the element, x is an element of all real numbers. And that is that. So very straightforward. 5 divided by x, that's straightforward. That x cannot be 0. Same thing, we're going to write in set notation. Right, so x is such that x is not equal to 0. X can be any other real number. X minus 7, so x minus 7 cannot equal 0, so x cannot equal 7. And there we go. The most complex one we're going to run into here is the x squared minus 2x plus 1. How do we figure out what x cannot equal here? Well, we have to factor this. We have to simplify this, right? So we can take the x squared minus 2x plus 1. We can say, well, that will break into x minus 1 squared, as it turns out. So it's x minus 1 times x minus 1. So in both of those scenarios, x minus 1 cannot equal 0. So x cannot equal 1, and then we just write our final domain. And there we go. That would be how we would work our way through example 1. Let's take a look at our second example here now. Okay, so moving on to the second example is now when we start to actually simplify these rational expressions. It says simplify and state the final the answer with non-permissible values. I'm going to go to the notes here again, so you'll see that there's a point made here, and they tell you exactly how to do this, right? So the first thing we do is we need to factor these completely if they're non-factored. So we look at these, yes, we can factor them. Then we find the non-permissible values. Then we cancel out anything we can, and then we can write our final answer and state our non-permissible values. So that's what we're going to do for this example here. So we start with x squared minus 9 over x squared minus x minus 6. So our first step is going to be, of course, we can't do anything with this until we factor these out first. X squared minus 9, difference of squares, so that's going to be x plus 3, x minus 3. x squared minus x minus 6, of course we factor that, and that is going to be a minus 3 and a plus 2. Right, so there we go, and this is where we find out that using our denominator that we know that x cannot equal 2 and x cannot equal 3. Just by saying x plus 2 can equal 0, x minus 3 can equal 0. So we have our non-permissible values ready, and then we can continue the question, right? So now we're looking to cross off, so we have an x minus 3 divided by an x minus 3. Those will cancel out because that'll be equal to 1 right there. So our final answer is simply going to be x plus 3 over x plus 2. We're going to put a little comma, and then we're going to state the fact that where x cannot equal right, our non-permissible values 2 and, oh, did I write? That should have been a negative, right? A negative 2 and a positive 3. And that is it. We have a simplified rational expression. Same thing down below. We have an x squared minus 3x over x. Can we factor this? Yes. Right, we have an x squared minus 3x. We can take an x out of both of these and turn this into x times x minus 3. So that's more simplified. And we have the x as our denominator. Again, so it's now in factored form. Now I can look for non-permissible values where x cannot equal 0. What can I cancel off? I have x times x minus 3 divided by x. So of course, these will cancel off, and I'm left strictly with, so x minus 3 is going to be the answer where x cannot equal 0. And that is the first two examples. I'll reset and we will go over the next ones as well. Okay, so for our next two examples, the same process is happening. 6x squared plus 3x over 3x squared. I'm going to simplify as far as I can, which means try to get rid of any of those exponents, right? So 6x squared and 3x. I can pull a 3x out of the 6x squared and turn this into 3x times 2x plus 1. 3x squared, again, it might look simplified, but we can in fact still pull an x out of there. We can pull a 3x out of there if we want to be more specific. So 3x times x. So again, I still have this broken down into most simplified form. What am I doing here as I have it simplified all the way? Right, so 3x times x. So again, 3x cannot equal 0, x cannot equal 0, so x. In both of these cases, we're getting the same non-permissible value for both of those terms, right? So x cannot equal 0. So I got my non-permissibles. I can now continue the question. Wait, I have 3x times divided by 3x times. I can cross off my 3x's. And I am left straight out with 2x plus 1 over x, again, where x cannot equal 0. So there we go. That is going to be example C. Example D is a good one. We do come across this occasionally, and this is something that I've tried to say when we were doing the factoring before. I don't like having my lead coefficient be a non-variable. We should have learned this in grade 9 math, right? When you're writing a polynomial, it should be like, right, your x cubed, and then your x squareds, and then your x's, and then your constants. There's that typical order of writing things. So when I'm writing this one, I need to correct that. So I have the x minus 3, and I'm just going to flip these around. I have a negative x and a plus 3. Now the problem with this, again, is always going to be that lead coefficient being a negative is in fact an issue. So we are going to have to eliminate that by dividing out negative 1. So I'm going to divide this entire binomial by negative 1, so it's negative, and it'll become x minus 3. So at first it didn't look like they were going to be able to cancel off, but if I follow the rules, writing this in the proper order, variables first and then constants, if I follow the rule with not having a negative lead coefficient, then all of a sudden this turns into something a lot more recognizable. At this point I have that x minus 3 still can't equal 0. So x cannot equal, oh, that was smart, wasn't it? So if x minus 3 can't equal 0, then x cannot equal 3. So now I still have my non-permissible value. Then we're going to look at, well, x minus 3 divided by x minus 3, so those cancel off. And I don't get left with nothing, I get left with a value of negative 1. Of course, where x cannot equal 3. So that is 2C and D done and explained. One more example for this, and then we can move to the next example, number 3, after that. And our final one for example 2, of course, is E125x cubed times y to the power of 4 over 5x squared y squared as well. Again, so this one they just show again. We'll show it by expanding the full way, right? If we wanted to simplify this as far as we went first, we would in fact still write this the old classic way. 125 times x times x times x times y times y times y times y. Right, that is fully expanded out. That is simplified. 5x squared y squared, so 5 times x times y, and again, this is stuff we get in grade 9 math, so hopefully we're not going to have too much of an issue with this. So of course the 125 divided by 5 will simplify. That's going to be 25 is what that's going to come out to. These x's cancel, these x's cancel, these y's cancel, these y's cancel. And I missed the non-permissible values because they're pretty straightforward, right? Where x simply cannot equal 0, y cannot equal 0. Those ones are a little more straightforward. So our final answer, of course, 25. I've got the bottom completely canceled off. I have an x times y squared, where x cannot equal 0, y cannot equal 0. So again, that one should be fairly straightforward. We're going to be ready to move on to our third example next. This here would be our third example. All it's asking us is, what does it say? Sorry, is the domain of this rational expression all real numbers except for x equals negative 3? Well, let's find out. Simply, we just got to do what the rules tell us to do, right? Factor first and find our non-permissibles. So this becomes x plus 4 and x minus 3, right? Difference of squares, so this is x plus 3 and x minus 3. So they had canceled. The thing is, what happened here, I'm thinking they did in this example, is they said that xe cannot equal negative 3. So they canceled off, and they said x cannot equal negative 3. But before, you're supposed to check your non-permissibles before you cancel off. So they did in fact miss the fact that x also cannot equal 3. So no, that is not correct. What they're asking us, all real numbers except for x equals minus 3, it is going to be x cannot equal plus or minus 3, and that would be the correct answer for that rational. They didn't ask us to solve this when they just asked about the domain. So that is example 3 explained. So next we can take a look at example 4. And is that our, oh, we got 2 left. Sounds good. All right, example 4 is asking us to create equivalent rational expressions and state the non-permissible values. So basically what it was trying to say is we can do anything that we want with this as long as we are multiplying by 1, which means we could have multiplied by x as long as it's x over x, because that's equal to 1, right? We can multiply it by 1,000 as long as it's 1,000 over 1,000, because that's still equal to 1. So that's all we're doing is, but they're asking us to use a binomial to expand this. Just a good couple refreshers here. So x plus 6 over x plus 2. I'm just going to use the ones that they chose in the book. So they chose x plus 8. So they said, okay, let's create an equivalent one by multiplying this by x plus 8 over x plus 8. So again, I am multiplying by 1. Before I start going any further here, I should take a look and make sure, again, if this is what I'm choosing to use, I need to say, okay, well, what are my non-permissible values before I start smashing everything together here? So what, x cannot equal -2 or -8. So I am going to still have some non-permissibles even for my add-ins, because we're going to be going to the expanded trinomial of this, right? So x squared, 6x and 8x is plus 14x, and 6 times 8 is 48. X plus 2 times x plus 8 is going to be x squared, 2x and 8x is 10x, and 2 times 8 is 16, where x cannot equal -2 or -8. And that was it. So we just chose our random value to multiply this by, and we expanded. Of course, in B, they had to try and be tricky and be overcomplicated here. So they chose, they have an x squared minus 3 over x minus 7, and they chose to multiply this by x squared plus 1 over x squared plus 1. Again, so we can still say, before we start to smash these guys together, multiply, FOIL through, we would still need, say, x cannot equal 7, and here x squared plus 1 cannot equal 0. So again, x squared cannot equal -1. So x squared cannot equal -1. So the square root of x cannot equal the square root of -1. There is no non-permissible value for that. So again, this one doesn't come with a non-permissible value. So our only non-permissible value is going to be that x cannot equal 7. Just multiply these through and we will be complete our question. X squared times 1, 3 times x squared, 3 times 1, right, x times x squared is x cubed plus x minus 7x squared and minus 7. Am I simplified as much as I can? No. Am I written in the proper order of polynomials from the highest degree, highest exponent to the lowest? No. So there's a couple things I can do to tidy this up. So I can combine the x squared, so x to the power of 4 plus 4x squared plus 3, so that is the most simplified version of this one. This one, I have an x cubed, an x squared, and a constant. They're just written in the wrong order. So it would become the x cubed minus 7x squared plus x minus 7, where x cannot equal 7. And that is that question example done up. So we only have one example to go, and this lesson is done. So the final example is asking to find errors, and I really like these questions. This also, I'm a fan of this because you have to understand what's happening to be able to see what somebody else has done wrong. Plus it gives me a chance to say, hey, you as students, this is what I have to do as a teacher when I'm looking at your work. I have to be able to find out where the problem is, where the mistake was made. I found the easiest way to look for other people's mistakes is to take the original question, just complete it the way I would normally, and then I look back to say, where did our answers start looking different? That's where they made the mistake. So here we just know that they made a mistake. 4 minus 8x over 8, they took it to 4 minus x over 1, which is just 4 minus x. So where's the problem with this? The one thing is I'm going to look at this as, so I'm going to just rewrite. As I said, the way I do this is to start from scratch. So when I start with 4 minus 8x over 8, I got to realize that there are the number of terms in here. I have so many terms. I have 4, I have an 8x, and I have an 8. There's 3 terms here. To simplify, I need to have all 3 terms divisible by the same amount. So I can take 4, 8x, and 8, and I can all divide each of those by 4 and get the same response. So then that would take me to, right, 4 divided by 4 is 1. 8x divided by 4 is minus 2x, and 8 divided by 4 is 2. And if I look at it right there, that was their problem, is they treated this, so they just pulled just the, divided just the 8x by 8, they left the 4 alone. No, we cannot do that. We had 3 terms, they all must be divisible by the same thing. Same thing below, in example B, x plus 1 plus 6, 3 minus x plus 1 equals, and then the thing is, this is not even simplified yet. This is x plus 1 plus 6. We can simplify that further. So again, if I rewrite this entire thing just to help myself along, so there's a couple things here. One is there is 1, 2, 3, 4 terms here. They all need to be divisible by the same thing. The other problem is this is not even simplified. So there's so much wrong with this, I can't even tell you where to start. So I'm going to rewrite. I am going to collect like terms. I have an x plus 1 plus 6. I can transform this. I can make this simply x plus 7. I have a 3 minus x plus 1, which of course is going to be 3 minus x plus 1. Whoops, so that should be the 4. Sorry if I collect my like terms. 4 minus x. And again, your notes will tell you to quit there. I don't like quitting there. I still like to have this rearranged. I want my x first. It's going to become negative x plus 4. I don't like that. Right? So x plus 7 over negative x. Now I have a negative lead coefficient, which is not a good thing, so I'm going to divide out the negative 1 to make that go away. So your answer book says to keep it as x plus 7 over 4 minus x. I'm saying we need to keep going. This is going to become x plus 7 over negative x minus 4. Just to keep that in mind, as you continue math, that's going to be the more common way to see things, is to be taken to that next level. That is the end of the 5th example. So you are free to get your butts in gear and work on the assignment 2.2. Make sure you send those in, and we will get you through and on to the next lesson after that. Thank you.